Methods of science. This is going to be an introduction into your physical science class. So starting off with what is science? Science is a method for studying the natural world. Okay, so it's broken up into three major categories. The first is life science, which is the study of living things. The second is earth science, and so this is going to be the study of earth and also of space. And then lastly, we have physical science, which is what we are going to be studying throughout the year, which involves matter such as atoms and compounds and energy. So to start, let's just review the scientific method. This should be review from your biology class. So the scientific method is just an organized set of investigation procedures for problem solving. Okay, so there's some kind of question and we're trying to solve it based on the investigation or experiment. Okay, so the first step is stating a problem. So there has to be some kind of question that we have to start with in order to start the scientific method. The second is to research and gather info. The third is to form a hypothesis. So this hypothesis is just a proposed answer to a question. Okay, so you have the problem, the question in front of you, and so it's kind of like your guess at what is going to happen throughout the experiment. Number four, test the hypothesis. This is also known as the experiment. Okay, so in the experiment, we're going to have different variables that we're going to be observing. Okay, so there's two different types. We have the dependent variable. This is the value that's actually going to change based on the other variable, the independent variable. Okay, so this is the one that we're actually going to measure, whether that's like the height, the speed, different things. We'll kind of go through examples here in a bit. The second is the independent variable. This is the variable that we actually change. Okay, so whether a lot of times it's going to be time, but it can be like the weight of an object. We change the weight of the object and then we observe what happens whenever the weight is different. Okay, so for example, if we had a car and we were running it down a ramp, if we add more pennies to it, is it going to make the car faster? Okay, so the amount of pennies is the thing that we are changing. So the amount of pennies that we add to the car, that's going to be the independent variable. Okay, and the thing that we're measuring is the speed of the car. So basically the time it takes for the car to get down that same ramp every time. Okay, within an experiment, we also have constants and controls. Okay, so a constant is a factor that does not change when other variables change. So for example, the freezing point of water is 0 degrees Celsius. Okay, if we go back to the pennies and car experiment, it would be that we use the same car every time and it's the same ramp angle and distance. Okay, a control is a test results that are compared. It's the standard, and so it's going to contain a constant. Okay, so if we look back at the pennies experiment, this would be a car with no pennies. So that would be our baseline, and then our experimental would be all of the cars with added pennies. Okay, step number 5 in the scientific method is analyzing the data. Okay, so we've collected all the data through our experiment, and so then we're going to analyze it. Generally, we're going to organize it in some kind of either data chart or graph. And then we're going to draw a conclusion. And generally, there's other steps included, like presenting your information or presenting your data, but I kind of just organized all of this into just drawing a conclusion, because generally whenever you write up a conclusion, it's going to include those steps as well. Okay, so here is a practice problem for us. So our experiment scenario, a biologist wonders if temperature can affect weight and growth. He believes that mice exposed to warm temperatures would grow bigger. He set up an experiment to study 9 mice. On day 1 of the study, the mice were measured for a variety of characteristics. Then the mice were put into individual cages and kept under the following conditions. Okay, so Mice 1, 2, and 3, they had 14 hours of light per day, food 1 time per day, and they got 5 ounces. Their temperature was 70 degrees Fahrenheit. They did have a wheel for exercise, and their cage size was 3 feet by 1 foot. Okay, so if you notice, mice 4, 5, 6, and 7, mice 8 and 9, they have very similar situations. There's only one thing that is being changed. Okay. After the study, which lasted for 28 days, the same data about the mice was collected. Some of the data is given below. Okay, so for our first question, what is the question posed? Okay, so I want you to go back, read over it. Okay, and so if we look in the scenario, a biologist wonders if temperature can affect weight and growth. Okay, that first sentence tells us the question that is being posed. So, can temperature affect weight and growth of these mice? Okay, so what is the hypothesis? If we read on, he believed, okay, so that kind of gives us a hint that that's going to be our hypothesis. He believed that mice exposed to warmer temperatures would grow bigger. Okay, so he thinks that warm temps could cause greater weight and growth in these mice. Okay, so if we look at constants, remember constants are things that are being held the same for each trial or each experiment. Okay, so looking at the box, we can kind of look at what matches between the all 9 mice. Okay, so things that are kept constant are things like the amount of light, so they're each getting 14 hours of light per day. The amount of food, they're all getting fed once per day, 5 ounces. They also have an exercise wheel, and then their cage size is all 3 foot by 1 foot. Okay, so those are all the things that are kept constant. All right, the next question, number 4, lists the independent and dependent variable. Okay, remember the independent variable is the thing that we are changing. The dependent variable is the thing that we are measuring based on the change that we've made. Okay, so our independent variable is going to be temperature because that's different for each set of mice. So we have a set of mice at 70 degrees, a set of mice at 85, and then a set of mice at 50 degrees. Okay, and so then our dependent variable, or thing that we're measuring, is going to be our weight and length. Okay, so we have weight in grams and length in centimeters in the data table provided. Okay, so then for number 5, I want you to conclude what you can draw from the data. Okay, so looking back at it, can we state that yes, his hypothesis was correct and that with higher temperatures, the mice are going to grow bigger? Okay, so the higher temperature mice would have been mice 4, 5, 6, and 7. So did they grow a greater amount than the colder mice, which were mice number 8 and 9? So just go ahead and put your conclusions on number 5.